Hello students, welcome back. Let us continue with chapter 6, lines and angles, and a new topic to start is parallel lines and transversals. So let's take a look at what are transversals. You must have studied in your 8th grade Hello students, let us continue with chapter 6, lines and angles, and the new topic to be covered is parallel lines and transversal. So what do you know about transversals? Transversal is a line that intersects two or more lines at distinct points, correct? So let's say I have two lines and I have this line intersecting these two lines. Let's say I call these lines M and N. And I have a line L, it is intersecting lines M and N in two distinct points, let's say P and Q. Therefore, L is known as my transversal. So now when this line is intersecting the two other lines, that is L is intersecting two other lines, it is forming certain angles. Let's mark these angles. We have these angles. Correct. We also have names for some these angles. We'll see that, but first let's mark these. I'll call this angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. Right? So what are the different angles that are formed? First of all, we have corresponding angles. What are the corresponding angles? Angle 1, angle 5. So angle 1 and angle 5 are corresponding angles. Similarly, on this side of the transversal, we have angle 2 and angle 6 as corresponding angles. Correct? Now, if you invert this, if you look, see, now I was seeing from top to bottom. If you look from bottom to top, you have angle 8 and angle 4 as corresponding angles, and angle 7 and angle 3 as corresponding angles. So let's write down the corresponding angles. We have angle 1 and angle 5. Then you have angle 2 and angle 6. So 1 corresponds to angle 5, angle 2 corresponds to angle 6. You can't say that angle 1 corresponds to angle 2. They are not corresponding. These are pairs, right? 1 and 5 are a pair of corresponding angles. Similarly, 2 and 6 are a pair of corresponding angles. Then, which is the other pair? You have 8 and 4. And finally, you have 7 and 3. 7 and 3, right? So, this was about corresponding angles. Then we have another pair of angles which looks more like a Z. Not really this Z, but it could be either this Z or it could be like this. So anything that goes like this angle and this angle are pair of alternate interior angles or interior alternate angles. So what are these pairs over here? Take a look. See, you have this line going like this, correct? So this is a Z here. So angle 4 and angle 6 are alternate interior angles. Similarly, if you go like this, you have angle 3 and angle 5 are pair of interior alternate angles. So let's write our interior alternate angles. Or alternate interior angles. We have 4 and 6. So 4 and 6 form a pair of alternate interior angles, and we have 3 and 5. Right? So this was about alternate interior angles. Now which are the other pairs? We have interior angles on one side. So if you see this transversal, the interior angles on this side of the transversal are 4 and 5. Similarly, the interior angles on the other side of the transversal are 3 and 6. So let's write these down. Interior angles What are my interior angles? 4 and 5. These are pairs, right? So 4 and 5 are a pair of alternate interior angles, and 3 and 6 are a pair of, sorry, not alternate interior angles, just interior angles on the same side of the transversal. Correct? So these two are on the interior angles on one side of the transversal, and these two, that is 3 and 6, are interior angles on the other side of the transversal. Then what are we finally left with? We are left with alternate exterior angles. So we had a way of finding the corresponding angles, alternate interior angles and interior angles. It was very simple. Corresponding is just when you look like this and like this. For alternate interior, we had a Z, and then interior angles on one side, we just have to look at the interior angles on either sides of the transversal. How about alternate exterior angles? If suppose you're looking at angle 2, you're going to look at this angle 8. So they are sort of vertically opposite, but one would be on line M and one would be on the line N on the outward side in opposite direction. So angle 2 and angle 8 are alternate exterior angles. Similarly, angle 1 and angle 7 are alternate exterior angles. Let's write these down. Angle 1 and angle 7 and angle 2 and angle 8. So 1 and 7 are a pair, 2 and 8 are a pair. 1, 7, 2 and 8. So these are the 4 different types of angles formed when you have a transversal intersecting two lines in two distinct points. So here we had two distinct points, P and Q, and the 4 kind of angles formed. But here M and N were just two simple lines. We did not consider them whether they are intersecting or whether they are parallel. But now we are going to talk about parallel lines and transversal. So let's see what happens when the two lines are parallel. So I'll draw two parallel lines. And I'll give the same naming convention. That is, I have transversal L intersecting lines M and N in two distinct points P and Q. Correct? And I'll mark these angles. 1, 2, 3, 4, 5, 6, 7 and 8. Now when you would draw these two parallel lines and a transversal intersecting them in two different points, what would you notice? Take a protractor and measure these corresponding angles, that is, measure angle 1 and angle 5. You will notice that angle 1 is equal to angle 5. You will also notice that angle 2 is equal to angle 6. Also, you will notice that angle 3 and angle 8 are equal, and also angle 4 and angle 7 are equal. So when you measure, you get the corresponding angles equal. Therefore, for parallel lines, and transversal intersecting them in two distinct points, what is your observation? Your observation will be that angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 3, angle 3 is equal to angle 8, and angle 4 is equal to angle 7, which implies that the corresponding angles are equal. And because of this measurement, just by measuring, we found that the corresponding angles are equal, which is why you have an axiom in your textbooks, which is axiom 6.3, that states if a transversal intersects two parallel lines, then the pair of corresponding angles are equal. Right? So when a transversal intersects two parallel lines M and N, the pair of corresponding angles formed are equal. Right? This was axiom 6.3. So now if we consider this to be given, if a transversal intersects two parallel lines and then the pair of corresponding angles are equal. Here this is the given and this is the conclusion, right? Let's find the vice versa, reverse of this. That is, if a pair of corresponding angles are, if a transversal intersects two lines and the pair of corresponding angles are equal, then the two lines are parallel. Let's find this out. So we need to find whether if a transversal intersects two lines such that the pair of corresponding angles are equal, then the two lines are parallel. Let's see how to find this, whether this statement is true or not. So erasing this side of the board. What you are going to do is, you are going to take a line, straight line AD, AD. Okay, you are going to mark 2 points B and C, and you will draw angles ABE and ACF such that angle ABE is equal to angle ACF. Right? So here I am going to write angle ABE is equal to angle ACF. Right? Once this is done, extend this line on the other side of line AD, that is, extend EB on the other side of ED. What you will notice that these two lines are not intersecting. So your observation is, I'll mark these as P and Q, that BP and CQ are not intersecting. Also, if you take a ruler and you measure the perpendicular distance, just take a point on this BP. Let's say I take a point here and I mark a perpendicular here on line CQ. Suppose if this is 3 units, take another point on BP, draw a perpendicular on CQ. You will notice that this is also 3 units. Take it vice versa. If you take any point on Q and draw a perpendicular on P, you will notice that this length is also 3 units. So there is equal distance between these two rays, right? BP and CQ. Therefore, what can you say? That these two lines are parallel. Therefore, the two lines are parallel. So therefore, for axiom 6.3, we have its vice versa true also, or its converse true as well, which is going to be your axiom 6.4, which states if a line intersects two lines such that the pair of corresponding angles are equal, then these two lines, here we have these two lines, then the two lines are parallel. So these are the axioms that we have, axiom 6.3 and axiom 6.4 pertaining to transversal parallel lines and corresponding angles. Now based on these axioms, we will have certain theorems. So the first theorem that we will be looking at is for alternate angles. Please note, these are axioms, they are universally accepted. So now let's say I have two lines, two parallel lines, M and N and transversal L, intersecting lines M and N in two distinct points P and Q. Correct? I'll mark, first of all, these are parallel lines, therefore the corresponding angles are equal. These two angles are equal, right? But this angle is equal to this angle, why? Vertically opposite angles, correct? What we will do is, we will give names to these lines and angles. So I'll say A, B, R, S, C, D. So I have transversal RS intersecting parallel lines AB and CD, in two distinct points P and Q respectively. What is my observation? Since AB is parallel to CD, correct, and line RS is the transversal, corresponding angles are equal. Therefore, what do we have? Angle AP, wait, and angle RS, angle APA, RPA or APR is equal to angle CQP. Why? Because they are corresponding angles. Correct? But angle APR is equal to angle APB is equal to angle APR is equal to angle QPB. Why? Because they are vertically opposite. We have learned that vertically opposite angles are equal. First of all, I'll mark this statement as 1. But angle APR is equal to angle QPB. Correct? Why? Because they are vertically opposite. Or I'll say VOA, vertically opposite angles, and I'll mark this statement as 2. So from 1 and 2, what do you get? From 1 and 2, you get CQP is equal to QPB. Why? Because according to the axiom that we learned in chapter 5, Euclid's geometry, that equals that are equal to the same things are equal. So equals that are equal to the same thing are equal. So therefore, you will have CQP is equal to QPB. Therefore, from 1 and 2, what do we get? Angle CQP is equal to angle QPB. So CQP, QPB. So this angle is equal to this angle. But these are a pair of alternate angles. But these are a pair of alternate interior angles. Very important. Similarly, you can prove that angle APQ is equal to angle PQD. Similarly, we can prove that angle APQ is equal to angle PQD, which is again a pair of alternate interior angles. Therefore, what can we say? That for two parallel lines and a transversal intersecting these 2 points, these lines in 2 distinct points, the alternate interior angles are equal. Therefore, we have a theorem 6.1. Let me confirm it if it is 6.1. Just hold on. It is theorem 6.2. if a transversal intersects two parallel lines, then the pair of alternate interior angles are equal. Right? Now let's go ahead and find the converse of this. So the converse of this will be what? You need to find that if a transversal intersects two lines such that the pair of alternate interior angles are equal, then the two lines are parallel. So let's write this down. The pair of alternate interior angles are equal, then the two lines are parallel. Correct? So how are you going to do this? Again, let's take this same figure. I'll erase this section. We have lines AB and CD getting intersected by a transversal RS at two distinct points P and Q respectively, and it is given that the pair of alternate interior angles are equal. That means, suppose I call this Q, this angle is equal to this angle and also this angle is equal to this angle. But for now we will take into consideration APQ is equal to PQD, right? So let's just do this. Given that angle APQ is equal to angle PQD, correct? Because they are the pair of alternate interior angles and it's given that they are equal. But now what do you see? You see that APQ and RPB, they are equal. Why? Because they are pair of vertically opposite angles. But angle APQ is equal to angle RPB. Why? Because they are vertically opposite angles. I'll mark this as 2. Again, from 1 and 2, what do we get? That PQD is equal to RPB. That is, the angles PQD is equal to angle RPB. Therefore, from 1 and 2, using the axiom that equals that are equal to the same thing are equal to each other. So, angle PQD is equal to angle RPB. Similarly, you can prove what? That angle APR is equal to angle CQP. But similarly, we can prove what? That angle APR is equal to angle CQP. I'll mark this as 3 and 4. But 3 and 4 are a pair of corresponding angles. See, PQD and RPB. You have PQD and RPB. They are pair of corresponding angles. Similarly, RPA is equal to angle PQC. CQP. CQP and APR, they are a pair of corresponding angles. Similarly, you can prove for the other angles also. That is, this angle is equal to this angle and this angle is equal to this angle. Therefore, what can we say? That, therefore, lines AB and CD are parallel. So this becomes your theorem 6.3. Sorry, theorem 6.3. Yes. So if a transversal two lines such that the pair of alternate interior angles are equal, then the two lines are parallel. Now we have these. We have proved these two theorems. We have two more theorems. We need not really prove them. I'll write them down for you. Theorem 6.4. What does it state? That if a transversal intersects two parallel lines, then the sum of interior angles, are supplementary. We'll check this for word to word from your textbook, but what do I mean by this theorem is that if I have two parallel lines and there's a transversal that intersects them, then the sum of these two interior angles is 180 degrees and the sum of these two interior angles is 180 degrees. And for this we have the converse as well, but before I proceed to the converse, let me just confirm this with the textbook. It reads out that if a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal are supplementary. So let's rewrite this. Two parallel lines, then each pair of interior angles on the same side of the transversal are supplementary. Right? Similarly, like how we had converse for 6.2, the converse was 6.3, we have the converse for this as well. This will be theorem 6.5, which will be if a transversal intersects two lines such that each pair of interior angles on the same side of the transversal are supplementary, then the two lines are parallel. Right? So let us quickly revise what we have done, because we have learnt about corresponding angles, alternate angles, as well as the sum of interior angles. We'll quickly revise it. If I have two parallel lines AB and CD and there's a transversal that intersects them, I'll say MN at points P and Q respectively. This angle is going to be equal to this angle, correct? And this angle is going to be equal to this angle because they are corresponding. Again, this angle will be equal to this angle and this angle will be equal to this angle. Why? Because they are corresponding angles, correct? So corresponding angles are equal for parallel lines and transversal. Now alternate angles. So interior alternate angles are equal. This Z is equal and this Z over here is equal. So the alternate interior angles are equal. And what about the pair of interior angles on the same side of the transversal? This angle plus this angle will give you 180 degrees, correct? This angle plus this angle is going to give you 180 degrees. So the interior angles on the same side of the transversal, they are not equal, but they will sum up to give you 180 degrees. So 180 degrees here and 180 degrees here. So what have we seen for? We have seen for corresponding angles, right? Alternate interior angles. And what else? For interior angles on same side of transversal. So we haven't really seen anything for alternate exterior angles. Okay, so there was nothing really, no proof or axiom for alternate exterior angles. With this we wind up with the first section of parallel lines and transversal. We'll take a look at the next section where there are 3 lines or maybe 2 or more lines parallel to each other and the transversal intersects them in distinct points. So we'll take a look at that in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.